There are four main classes of biochemical molecules in the body: fats, carbohydrates, proteins, and nucleic acids. This video will be discussing fats, otherwise known as lipids. Fats are almost exclusively made of just two of the atoms on the periodic table, carbon and hydrogen. Because carbon and hydrogen always form nonpolar bonds with one another, this also means fats are nonpolar molecules, and that they do not mix well with other molecules in the body, which are mainly polar. The main fats in the body include fatty acids, triglycerides, phospholipids, cholesterol, and eicosanoids. Let's start with fatty acids. Fatty acids are long chains of carbon surrounded by hydrogens. At the end of all fatty acids is a carboxylic acid group. There are between 4 and 24 carbons in the fatty acids commonly found in the body. If a fatty acid has no double bonds between its carbons, it is called a saturated fatty acid. This is the 16-carbon saturated fatty acid called palmitic acid. By adding 2 more carbons, we can create the 18-carbon fatty acid stearic acid. Fatty acids with double bonds between their carbons are unsaturated fatty acids. A fatty acid with only one double bond is called a monounsaturated fatty acid. This is the omega-9 monounsaturated fatty acid, oleic acid, which makes up about 70% of the fatty acids found in olive oil. It is called an omega-9 fatty acid because its first and only double bond is at the 9th carbon from the omega end. Fatty acids with multiple double bonds are called polyunsaturated fatty acids. This is the polyunsaturated fatty acid alpha-linolenic acid. This is an omega-3 fatty acid because its first double bond is 3 carbons from the omega end. Also notice that these double bonds cause the fatty acid to have a bench shape. This is important because the bench shape of unsaturated fatty acids means they do not pack together as well as saturated fats, which have a straight shape. For this reason, unsaturated fatty acids do not form solids as easily and so tend to be liquids at room temperature. Highly saturated fats like butter and coconut oil are solid at room temperature, whereas fats that contain large amounts of polyunsaturated fatty acids like flax oil will remain a liquid even when put in the freezer. Also notice when you add a double bond, 2 hydrogens are removed from the molecule. Unsaturated fatty acids therefore also have fewer hydrogens. Another important characteristic of unsaturated fats is that they are more unstable than saturated fats. Saturated fats are very stable. They don't tend to react with other molecules, even when heated or exposed to light. The double bond in unsaturated fatty acids, however, makes unsaturated fats more reactive, especially when heated. For this reason, highly unsaturated fats like flax oil spoil easily and should be stored in the fridge or freezer in a dark container. Unsaturated fatty acids can also sometimes form what are called trans fats. Trans fats are unsaturated fatty acids that have changed shape at their double bond. Unsaturated fats usually have a bent shape at their double bond. This is called the cis shape. The cis shape puts the 2 hydrogens on the same side of the double bond. However, if we twist this unsaturated fatty acid at the double bond, the 2 hydrogens end up on opposite sides of the double bond. We call this the trans shape, and we call the fatty acids that have double bonds in this configuration trans fatty acids. These fats are concerning because these straightened fatty acids are not commonly built by most living things, and so are not found in large quantities in natural foods. Trans fats are formed in large quantities in partially hydrogenated fats. Research started linking high trans fat consumption with increased risk of cardiovascular disease, and so to reduce their presence in foods, partially hydrogenated oils have been banned in many countries, including Canada and the United States. There are also certain unsaturated fatty acids that are essential to our health called essential fatty acids. These include the omega-3 fatty acids and omega-6 fatty acids. Our body has the ability to make many fatty acids from smaller building blocks but cannot make omega-3 or omega-6 fatty acids. We must attain these from our diet. The omega-3 and omega-6 fatty acids are polyunsaturated fatty acids. The omega-3 fatty acids have their first double bond at the 3rd carbon from the omega end, and the omega-6 fatty acids have their first double bond at carbon 6. These fats have vital functions in our body and assist with our immune health, brain health, and much more. In the body, these fatty acids are generally not found by themselves, but rather are found as a part of 2 other very important molecules, triglycerides and phospholipids. Let's take a look at triglycerides. When our body has extra fatty acids, we store them by creating molecules called triglycerides. Triglycerides are created by taking a molecule called glycerol and linking 3 fatty acids to it. Triglycerides are the most abundant fats in the body. They are used mainly as a way to store extra energy and are stored in cells called adipocytes found around organs and under our skin. The second place we find fatty acids is a part of phospholipids. Phospholipids have a very similar structure to triglycerides. However, instead of having 3 fatty acids linked to the glycerol molecule in phospholipids, one of the fatty acids is replaced by a phosphate molecule. This small change makes a big difference to the overall function of the molecule. The phosphate portion of the phospholipid is polar and so is capable of mixing with water, while the fatty acids are nonpolar and so are hydrophobic, do not mix well with water. These phospholipids create the phospholipid bilayer found in all cell membranes. Another very important fat in the body is cholesterol. While some cholesterol in the body comes from our diet, we actually produce approximately 80% of our cholesterol. Like other fats, cholesterol is composed almost exclusively of carbon and hydrogen, with only one oxygen in the entire molecule. Cholesterol itself has important functions in cell membrane structure, and it is also found in bile and helps to emulsify fats. Cholesterol is also the precursor for the production of the body's steroid hormones, which include estrogen, aldosterone, testosterone, and cortisol. The final fat molecules we will discuss are the eicosanoids. These molecules are produced from fatty acids stored in the cell membrane of cells. Eicosanoids are important molecules with powerful effects that are created when we modify certain fatty acids in the body, namely arachidonic acid and EPA. There are many different eicosanoids that trigger a variety of important functions in the body, including inflammation, fever, pain, and various other cellular functions. In summary, fats are a very important class of molecules in the body. They are nonpolar and include fatty acids, triglycerides, phospholipids, cholesterol, and eicosanoids. All of our videos come with a multiple choice quiz, a short answer test, and a Public Kahoot that can all be accessed free of charge. The information for these resources can be found in the description below, or you can click this next video that explains how to easily access all these great resources. And if you're enjoying our videos, please hit the subscribe button.